Sorry for delay. Please give me just a couple of minutes. I'm going to setting some settings I have to manage here for host and co-host, so that it will be easy for smooth operation. So please allow me a couple of minutes. In meantime, we will just wait. The still participants are still joining, so let them join, and then we'll start. Okay, so now we'll start the first presentation. So Dr. Ajit.
Yes, sir. It's audible, sir. Sir, audible now.
Yeah,
Can I
Dr.
proceed?
Ajit. Yeah. But what is the technical problem here? The name Dr. Ajit Kumar Raut, right? You have in Galaxy F41. In Galaxy F41, I can make a co-host, but in the name of Dr. Ajit Kumar Raut, I cannot make a co-host. So can I make a co-host for this Galaxy F41?
You can proceed with the Galaxy S1. You can proceed. I'll try with the small device. I'll try.
Your audio is not clear. Yeah, I can make co-host to Galaxy F41,
Okay,
but
sir.
I can't make co-host to Dr. Ajit Kumar Rao name. So
Okay, sir.
I will make Galaxy F41 co-host, and then you can start.
Okay, sir.
Okay. Yeah, it's okay, but it's yes, Dr. Ajit, you can proceed. I already made co-host to you. Again, I would like to request the name G6. Could you please change? You can rename the name according to the presenter login name provided you or your paper ID. Just please add paper ID either or rename the presenter login name so that it will be easy to recognize your allocated time slot and your topic. Who is G6? Can you hear me, please? Yes, Doctor.
Sir, hello.
Yes, that's Dr. Ajit. Yes. Should I?
When I want to share in my Galaxy, only the host can share in this meeting. That option
Okay,
is
wait.
always.
Okay. Just I made the Galaxy F41 co-host. You can proceed now. Yes, please.
Sorry, sir, it's not displaying. So I'll go and start this thing, sir.
It's okay.
Because of somewhere some problems happening. The screen is not coming to the only image is coming. So the file is not
It's okay.
displayed.
It's
I
okay.
will start now.
Fix it and let me know.
Okay, sir. Good morning, distinguished guests, respected members of the organizing committee, fellow researchers, and esteemed audience. As I present my research work titled before you today with great pleasure and honor, in this conference paper, I aim to shed the light on identification and mitigation process for the air quality using machine learning techniques. So, the content what I will discuss the introduction, problem statement, existing system, proposed model or system, literature, and data sets we will in our work and result conclusion. I would like to express my heartfelt gratitude to our international conference providing this platform to share my research. So, as I mentioned here, the air quality. Air is the prime resource for a sustained supply in addition to land and water. So one way to describe air quality to report the concentration of all pollutants with the acceptable levels, or other way you can say standards. As the number of sampling stations and pollution parameters increases, in other way you can say their sampling frequency. Such a description of air quality tends to become confusing even for the scientific and technical community. Since awareness of daily levels of air pollution is important to those who suffer from illness caused by exposure to air pollution, therefore, the success of nation to improve air quality depends on the support of its citizens who are well informed about local and national air pollution problems and about the progress of mitigation efforts. To address the above concern, the concept of air quality index, that is called as AQI, air quality index, has been developed. I can say the problem statement, nothing but air pollution is one of the environmental issues that cannot be ignored. So inhaling pollutants for a long time causing damage to human health. So traditional air quality observance methods, though is available, observance stations are typically expensive in each and every places. This method is suitable for finding air quality based on AQI value to show how severe the air quality is and the steps to reduce the severity. So in the existing system, we can say there are available papers they have presented and they address the areas using aggregate long short-term memory LSTM based on the LSTM deep learning methods. So this model says combining local air quality monitoring system, the station in nearby industrial areas, and the station of external pollutant resources, they combine the aggregate three LSTM model into a predictive model. They have used PM10 and PM25 variable in finding AQI value. PM10 and PM25 nothing but called as a particle diameter, where PM10 says less than 10 and less than 10 microns, where PM2.5 is 2.5 and less. So this is the what variables they are using. The main drawback of existing system is there is a high composition of SO2 NO2 than PM10 and PM25. Then there is an increase in AQI value. So that is the way that this is the drawback. I want to represent in other way using different models to overcome this one. So proposed model is work with SO2, NO2, RSPM. These are the different variables we have taken by applying machine learning approaches, whose labeled numerical database ANN model for training the models. It contains two basic steps. First, to calculate AQI value, then AQI value given the quality of air. Objective is to inform public regarding overall status of air quality through a summation parameter that is easy to understand. Inform the citizens about the health impact of air pollution exposures. This is our objective of this paper. Then we have gone through literatures and comparison done about 4 to 5, 6 papers. One is a SMARTCYBER-2023 paper, that is nothing but a LSTM based aggregate model. Second one paper taken Springer air quality monitoring system e-health, and their advantage and disadvantage comparison done. Similarly, you have done another paper, deep learning for air quality forecast for our literature survey and all of them. They use RNN, LSTM, CNN, RNN. And similarly, we have done another paper, air pollution prediction using data mining techniques. We have done over comparison over 6 papers. Another paper also applying recurrent neural air quality. Elsevier, another paper, air quality prediction, Milan specific in one area. In that different comparison we have done, different models on neural network model starting with RNN, LSTM, GRU. These are all the different models of comparison done. So we proposed a model where the method consists of user interface. User need to enter the pollutant concentrations which are taken from the surrounding area. In the back end, these concentrations are processed to determine AQI value, which is a model then used to determine the air quality. So the proposed model shows the appropriate method taken based on the level of air pollution. On the basis of severity of the air quality, proposed model displays the mitigation steps, which include the causes of pollution, how to increase the quality of air, and preparation to improve the health conditions. So we use different machine learning models to observe their accuracy. From that, we will be taking the model which will be giving high accuracy, best performance than existing systems, remaining machine learning models. So our model is consists of first we have to take the input data, given a pollutant data, then input information, earlier past data, and then a meteorological department information will be added in the past data, pre-processing the data, machine learning algorithm apply, then you will be accuracy and then air quality and the mitigation steps will be present based on this accuracy and the given inputs. So data sets are nothing but called as Indian air quality has declined over the years. The WHO named the most pollutant nation in the world in the Indian air quality data set. Of course, thorough air quality measures from several Indian cities gathered from monitoring stations from 2015 to 20. We have taken the data sets. Data sets consists of state, location, type, SO2, NO2, RSPM, nothing but called as a respirable suspended particle matter and suspended particle matter. Similarly, sulfur dioxide, nitrogen dioxide. These are different. Then sulfur oxide, nitrogen. These are different. 13 parameters you have taken in the data sets and their values. Then you have gone for the data pre-processing technique. Then you have gone for these different models. As the model says, the model takes the different models, machine learning models, regression, random forest decision tree, k nearest neighbor. K nearest neighbors our proposed one, being that is not used by the other researchers in the different papers. So we have taken the same input as I told, 14 components or attributes are there in the input. You apply a different model. So for this evaluation techniques, we used accuracy, mean square error, and root mean square error. The model evaluation process, you give different evaluation metrics to understand a machine learning model performance. We using accuracy, mean square error, and root mean square error. So this all the things are there presented in this angle. So we have a accuracy of MSC, RMC, different comparison you have done. So k nearest neighbor is better compared to all other cases. So then you have gone for MSC, RMC testing data. In that also training, testing all the cases. We have proved that k nearest neighbor, KNN method is better compared to logistic regression or decision tree, random forest tree. These are different methods. So the steps are that told collecting pollutant data pre-processing, training and evaluation model, AQI classifications. AQI classification, as I told, we have to range the AQI air quality index. So we have given the range. Suppose 0 to 50 good division, then similar 51 to 100 moderate divisions. So it will go 150 to 200 unhealthy, 201 to 300 AQI value is very unhealthy, and 300 to 500 as per as hazardous environment. So in that way, you have given classifying this one, and followed by you have given each data set as labeling based on the AQI value. You have given the label. So different cluster or multi-cluster representing ANN. So based on that, you have identified the techniques. So the result says our KNN method is better compared to all other cases. So nothing but a linear regression, distant tree, random forest, as well as all other papers they have used in LSTM and all of these drawbacks of all other cases due to the processing time and data requirement. That these are the things, nothing but huge data required, same time memory process required for LSTM. These are the drawbacks. I have comparison study also mentioned. So our predicted model observed and predicted through scatter plot also shown almost all same and equal. So we can do that our proposed method work well. Scatter plot depicting the relation between predict and observed results. So actually we have one for even nothing but called as a facts represent the website. You are entering different values. After this back end, we capture the complexity of all the data sets and their correlations we captured and represented. When you will front end, you will enter different values of the components. Suppose you enter the value of SO2 or NO2, RSPM, SPM, different values. Then you will identify these values as the equations are correlation and the output will get as air quality index, good, bad, or worst, or unhealthy, or hazardous. So based on the design such a manner, so under which component it becomes as good or bad or waste. So for that description also we are presented. So this is all about talking about this one. Front end you design, you will give different components of the air quality. After capturing this one, so SO2 NO2 different all the things based on that air quality index you can make. And the index the index outputs are different 6 categories there. Each category will describe the descriptions about mitigation technique. If you reduce this component, you will reduce our AQI. This is the way you are represented. We have gone for this result with a different combination of inputs. Then in conclusion, I can say the proposed system used as AQI values prediction result of linear regression, decision tree, forecasting, k nearest neighbor is done. So we have chosen KNN algorithm predicting AQI because the KNN classifier is a simple and fast algorithm that suitable for large data sets. So moreover, KNN results, the less you can say MSC or RMS, the proposed model help identify good quality air quality, but also use mitigation steps to increase the air quality, improve the health conditions of the citizens. So then you have one reference paper near about 14 papers. This is all about, sir. As sorry to say, I will share my PPT in this form. I will see that one. I will share, sir.
So, okay. So we have got 5 minutes for question. If anyone would like to ask the question, then please ask your question. Does anyone have question?
Yes, sir, you can.
Well, since there are no questions, let's move on. I have one question. How can you ensure that your model is better as compared to other similar model? As you mentioned that you use 7 different models, if I'm not mistaken.
Yes, sir. I compiled with the 6 different papers, that the recent papers related to air quality index. Actually, normally the AQI value, and we have done categories of AQI values with the 6 categories. And in that again, each input data set we have given a label based on this category. And the same thing others have not. They have taken overall category at a lot they are trying to represent, where they are unable to represent it whenever it is an unhealthy condition, what which component out of different pollutants, which pollutant need to be reduced so that your AQI value will reduce. Such type of things they have not, that dimension they have not taken care. But we have done in KNN model where multi-clustering have done. Nothing but called as categories of AQI values. And giving the label yourself after pre-processing, we are giving a label to our input data sets. So that similar component if you give as input, then we can identify it belongs to which cluster and what need to do to make it to from cluster C. Suppose it is in the 5-6 category, whereas the ranges from 300 to 500, it is nothing but called as hazardous. In that, which component you can try to reduce so that you will come to this average or good level. That in that angle, no papers are addressed.
Okay, thank you, Dr. Ajit. It was a nice presentation. There are good scopes available for further improvement of your work. So thank you so much.
Thank you, sir.
And one more request. Could you please send your PPT to me?
Sure, sir. Now I'll send.
Yeah.
I'll send you. Thank you.
Yeah,
Sure.
Thank you.
Okay.
Thank you so much for your presentation. So, MS, can you hear me, please?
Yes, I can.
Can you rename your login, presenter login, so that I can recognize your time allocated time slot and the topic you are going to talk?
Yes, let me do that right now.
Yeah. Similarly, I would like to request G6. Who is G6? Could you please rename so that it will be easy to recognize the respective paper and allocated time slot? Okay, student 9. Is there a presenter? Is there a presenter of paper ID 2784? 2784. So, Dr. Ajit, could you please send me your PPT so that I can pass it to the participants and we can display in Zoom also. Okay, since we do not have presenter 6. Yeah, presenter 6. The presenter 6 is not available, so I'd like to utilize this time to present the PPT that the presenter 2 presented due to some technical error. He could not present it, so I would like to utilize that time and would like to share the PPT of presenter 2. Okay, so we have another presenter, presenter 6. Because of some reason, the presenter 6 cannot present physically using a Zoom virtual, but the presenter sent a video. So I'm going to present a video of presenter 6, and the topic is analysis of creative economic situation in Beckenborough statistical analysis and work cloud. So I would like to request all the participants to check the video. Okay, so that's the end of the video presentation sent by the presenter 6, Dedek, Adrian, and P. So thank you so much, Dedek and team, for your enlightening presentation. Now we'll move forward and we'll see the next presenter 7. Okay, so we'll have a break since there is no presenter 5, presenter 4 are not present so far. So we'll start presenter 7 after a break. Well, let's wait. Still, we have 15 minutes. If any presenter present, then we'll proceed. Otherwise, we'll start after short break.
Hello, is someone there? Hello. Hello, is someone there? Hello. Hello. Good morning, sir. I'm Aditi Arora.
Yeah. Good morning.
Sorry.
I cannot hear you, Aditi.
Yes.
Is your audio is okay? So you are presenter one, right?
Hello, sir. Am I audible now?
Yes, Aditi. Aditi, right?
Yes, I am Aditi Arora.
So Aditi, your presenter one. Your paper ID is 6867. Am I right?
Yes, sir. It's 6867.
So it's now it should be actually it should be presenter seven's turn, but as presenter seven is not here, so I will give you chance to present your presentation. So Aditi, you can proceed. I will make you co-host.
Yes, sir. Please.
Okay, go ahead.
Sir, is my screen visible?
Yes, it's visible. So your title is Application of Data Mining Methods and Technique for Diabetes Prediction using PIMA Indian Dataset.
Yes, sir. Sure, you are right. So first of all, thank you for this opportunity so that I can share my research work with you. So moving ahead, let me introduce you to the main problem. Nowadays, diabetes mellitus is the most common problem. Even a small 2-3-year-old child is facing this problem, and it keeps on increasing every day due to changing lifestyles and unhealthy food habits and overweight problems. Through my research, I have tried that we can predict diabetes at a high accuracy. I have used 3 types of models, which is SVM, support vector machine, K nearest neighbors, KNN, and naive Bayes. And nowadays, in these times, technology is booming, and data science methods have the potential to benefit from other scientific fields by shedding new light on the common questions. So, before going further, we should understand what is the cause and effect of diabetes. There are 2 types of diabetes, that is type 1 diabetes and type 2 diabetes. So understanding the primary cause of type 1 diabetes is that it's an autoimmune response that leads to the destruction of insulin producing cells in the pancreas. Whereas in the type 2, it's a combination of insulin resistance and impaired insulin secretion. And the common symptoms of diabetes are excessive thirst, excessive hunger, unexplained weight loss, blurred vision, slow healing and cuts and sore, and fatigue. And so, by these symptoms, we can understand that we are having some problem in our health. And this diabetes can cause harm to our heart, kidney, eyes, nerves, leading to so many health complications. So it's it's a necessary that the disease is diagnosed quickly. Like in my case, my personal experience, my father got diagnosed diabetes in 2014, and he never understood that what is happening with his body. And suddenly when he got diagnosed, it was 800 sugar level. So just see, so high it was, and could be anything. It could be so dangerous. So moving ahead, the objectives of this research is to improve diabetes classification by comparing data mining and ML techniques to traditional algorithms. So the data set I have used is PIMA Indian Diabetes data set, which is a widely used benchmarks data set in the diabetes research. Feature selection always helps in increasing the potential of the data set and accurate predictions of diabetes. Evaluation matrices that I have used are precision, recall, specificity, mean absolute error to assess the model performance. And I have also used train, test, split method and cross validation to enhance the accuracy and robustness of the prediction across all models. So let me introduce you to the data set. So this data set has origin from the National Institute of Diabetes and Digestive and Kidney Diseases, and this data set predicts the diabetes presence based on the diagnostic measurements. The patient characteristics are, it mainly focuses on the PIMA Indian females aged 21 and above to ensure a specific demographic representation. The medical vector variables are like pregnancies, BMI, that is body mass index, insulin level, age, and many more, which we'll see in the further slide. So the main target variable is the outcome, which helps us predicting that whether a person is having diabetes or not. So coming to the objective is to develop a predictive model to accurately diagnose and classify patients which have diabetes or not. So as you can see, this is the step from the diabetes data set. It has 9 columns, namely pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age, and outcome. And this is the histogram of all the 9 parameters, and it shows how the data has been distributed in these 9 parameters. So the methodology I have used is a 3-level architecture. The 3 levels are the data pre-processing, data modeling, and data evaluation. And this this model is for the type 2 diabetes. So in data pre-processing, we have done is to remove all the redundant, irrelevant data, performing feature selection and applying data normalization techniques to enhance model accuracy. Then comes the data modeling, which utilizes algorithms like naive-Bayes, SVM, and KNN to build diverse models for increased accuracy in predicting diabetes. And then evaluation matrices like precision, recall, specificity, correctness, and MAE, which is mean absolute error, are used to access the model accuracy on the test data. Employed to enhance the model precision and reliability by splitting the data into subsets, which is the training data and the testing data. And as in the image also, you can see how the model has been created. So let's discuss the results. And as you know that the constructive feedback forms the foundation building of machine learning models. So in the PIMA Indians diabetes data set, there are 2 binary values, which is 0 and 1. So 0 represents non-diabetic individual, whereas 1 representing the diabetic individual. However, in the data set, there are only 500 non-diabetic individuals and 268 diabetic individuals, and the data set is little bit imbalanced. So this is the correlation matrix, and in this correlation matrix, it tells us the correlation coefficient among the variables, which is the 9 variables we have discussed earlier. It arranges the variables in common columns and rows, with each table cell indicated a correlation coefficient. And brighter the color, the more is the correlation. So as we can see in the heat map, the value 1 indicates that the outcome variable significantly correlates with glucose level, age, BMI, and the number of pregnancies. And such a relationship between several factors such as age, a pregnancy, or insulin and skin thinning. Then next I had is the train test split method. A train test split method is when you split your data into training set and testing set. The training set is used for training the model, and the testing set is used to test the model. It is quite obvious from the name only. And this allows you to train your model on the training set and then test your accuracy on the unseen testing set, that how it reacts. So I have used 3 models, and according to these 3 models, and you can see in the table as well, SVM, support vector machine, gives us the highest accuracy, and whereas K and N, K nearest neighbors, give us the lowest accuracy, and it's visible in the graph as well. Then next is the K-fold cross-validation method. Cross-validation method is a method of testing ML models on a subset of data. It involves splitting the data into K groups, with K being the parameter that determines the number of groups. And we can take any number, like 10, 5, 6, 7, any number we can take for this method. So I have used 3 types, which is the 5-fold, 7-fold, and the 10-fold. And we can see that SVM and naive Bayes are giving us the good results compared to the K and N. And this is the graphical representation of the accuracies obtained using K-fold method. Then next is the confusion matrix. The confusion matrix is an interesting parameter. It has a square box having 4 parameters, which is the true positive, false negative, false positive, and true negative. As you can see in the images displayed in front of you, we have for the 3 models, the confusion matrix is there. So in KNN, the true positive is 101, whereas false negative is 18, false positive is 32, and true negative is 30. Where coming to SVM, it's the true positive is 110, false negative is 9, false positive is 30, and true negative is 32. And the naive Bayes, the true positive is 96, false negative is 23, false positive is 25, and true negative is 37. Then last is the evaluation matrices. I have used 6 different evaluation matrices, which is precision, recall, MA, specificity, accuracy, F1 score. And as we can see that SVM and naive Bayes are here also giving us a good result compared to the KNN. And this is the graphical representation of all the 6 evaluation matrices. The blue represents precision, orange represents recall, green represents specificity, red represents F1 score, purple represents mean absolute error, and brown represents accuracy. Then the last comes the conclusion. So in conclusion, it's very interesting. Focus on predictive analysis. And as I have discussed, my study aims to utilize predictive analysis and enhance classification methods to identify and address diabetic problems proactively and improving the overall quality of lives for individuals. And it's quite necessary, as I told you with my personal example as well. Dataset analysis and feature selection. The datasets features are analyzed and top features are selected based on the correlation scores to build a precise classification model. And the model, as much as the model will be precise, the better will be the results and better we can diagnose this disease. So the conclusion is that various classifiers give the accuracy of 67%, and their SVM, support vector machine, is exhibiting the highest accuracy of 78%. Almost every method I have used, and K nearest neighbor is always giving us the lowest accuracy. So in all the evaluation matrices as discussed before, SVM and naive Bayes have given us a strong result. So last scope for improvement, I won't say that my model is fully accurate, but there is a scope of improvement, and which I'll work further to enhance the suggested model for the studies. Incorporating the recent patient data and advanced techniques are recommended, and along with the establishment of predictive grading rules and standards to prevent the spread of diabetes. Thank you so much for this opportunity once again.
Okay, so we have now got 5 minutes for questions. If anyone would like to ask the questions, then please ask your question. Does anyone have question? You can ask. If you have any question, please ask. Well, since there are no questions, so let's move on. Aditi, right?
Yes, sir.
Hmm.
Aditi.
Okay, I have one question. As you say that you use 3 models, right? You compare with 3 different models. So how can you ensure that your model is better as compared to other similar models? As I know, in diabetic predictions, there could be several proposed models, right? Plenty of proposed models. So how do you think your proposed model is better as compared to other models?
I won't say that my model is the best one, but there is a scope of improvement in that. My model is similar to all those research papers I have studied, and it's getting the same accuracy, maybe 1-2% more only. So it's not the best one, but not the worst also, and it's
Okay.
for research purpose.
Okay. So among 3, SBM is the better one in terms of performance, right? In your research, in your finding, you said that SBM is the better.
Yes, sir.
So do you think SBM is better in terms of all the performance metric you have used or for a specific one? So far you use five performance matrices, right?
Yes, sir, 6 I have used.
6 out of 6. Yeah, this one precision. So SBM is better in all? No, right? So how do you you took it average?
Yes, I took the average, and according to that, SVM is always giving us better results compared to the other. Like out of 6, in 5, SVM is giving us the good results. So we can say that SVM is on the good side, not on the worst side, on the lower side.
Okay. So if does anyone have question? Okay, if not, so many questions, then thank you, Aditi, for this nice presentation. And I think there are good scopes available for future improvement of your work. And thank you so much for your participation.
Thank you, sir, for giving me this opportunity.
Okay, so we'll move forward. Let me check who is available. So presenter 11, presenter 9. Okay, else present. Okay, please.
So, sir, can I leave this meeting or I have to stay here?
Okay, so now it's turn for presenter 9. The presenter 9? Yes.
Yes, I'm around, Professor.
Okay, so the topic is sentiment analysis of tweets using bidirectional long short-term memory and word embeddings. So I will make you co-host and then you can proceed. Presenter. Make co-host. Okay. You can proceed.
This can be seen, right?
Yeah, it's visible, I guess. But can you move to the second slide? Ah, yeah, it's visible. Okay,
Okay.
go ahead.
So, good afternoon, ladies and gentlemen. My name is Oguru Matthew Amias, and this is my paper. My paper is on sentiment analysis of social media tweets using a bidirectional long short-term memory and word embeddings. So I'm going to, I divided the presentation into 3 parts: the introduction, part 2 is applications and contribution, and part 3 is the final part. So in part 1, I'm just going to give you a brief background on hate speech in social media today. So over the past decade, the number of people using social media has grown exponentially with Twitter, Facebook, WhatsApp, all these places emerging.
Sorry, Matthew.
Yes,
I just interrupt you. Could you please make your slide full screen?
Okay.
Ah, yeah. Better.
So to continue from where I stopped, so with the emergence of social media networks such as WhatsApp, Twitter, the number of people use these platforms for various things. Some communicate with family, others use it to do business, but there are also, like everything in life, there's something has its own advantages and disadvantages. So with the increased number of people using social media, so has the increased number of hate speech usage, the number of attacks on immigrants and minority groups. By minority groups, I mean these attacks are mainly built around race, feminism. We have people who are targeting women with body shaming comments, targeting races with those kind of comments. And this has sort of led to cyberbullying. And this kind of environment has led to cyberbullying, and one of the ramifications of this is lower self-esteem and even suicides to some users. So this is a bar graph from Statista. It's showing the way tweets are, on Twitter. So we can check in the first graph. You can see that some tweets contain a lot of inaccurate or misleading information. And then in the second one, we can see that harassment and abuse is also very viral. Like it's a lot on Twitter. So my motivation for this is that the extensive use of social media for various activities, such as advertising, data visualization, content creation, and so on, has provided platforms for users to communicate unchecked. That means that anyone can say anything and there will be very little repercussions to what they're saying. So, permanence and possibility of coming back. This means that hate speech has been on social media for such a long time, and this hate speech continues to violate people's privacy. People post on social media looking for a platform to share their views, some views positive, some negative. So that's actually the purpose of this project. This project was done to detect this hate speech in early stages. Now, the main contribution to this project is that we developed a recurrent neural network. To be specific, that is the bidirectional long short-term memory network. We use this network because of its ability to the main feature of its state cells that can store long-term dependencies. Now, these long-term dependencies, they're very helpful when capturing the contextual meaning of tweets. Second, we used the sentiment 140 data set from Kaggle. It's a public data set, can be accessed on Kaggle anytime. It contains 1.6 million tweets, and it is unskewed. That means that half are positive and half are negative. So it was a bit easier to work with this data set. And then for evaluation, we used the confusion matrix. And at the later stage, we compared the model of this project with the Me2 model, which is a model by Francesco. They also used a similar technique. So this was the research pipeline. So first, we got the data set. We got it from Kaggle. Then we defined the problem, which is obviously the increased amount of related hate speech on the internet. And then we also wanted to work on improving the classification. Next, we had to prepare the data set, that is by removing unnecessary columns, because when you download this data set online, most times it comes in an Excel file, and then you have to transform it into a CSV to work with it in Jupyter. So we also did a little bit of pre-processing there. And then in the pre-processing state, we also did text normalization, analysis, tokenization, and padding. I'll get into that a little bit further down. And then finally, we did sentiment analysis. We use word2vec. Word2vec is a word embedding method. It was developed by Google. It's very good when we're capturing to capture the vector representations of words. It uses two methods. It uses the skip gram method and the continuous bag of words. We shall get into that a little bit deeper down as we continue the presentation. So let's go to the application and contribution. So first, this is the pipeline. First, we get the data set from Twitter. Once we get the data set, we perform text normalization and tokenization, then word embeddings, then we pass it on to the BiLCTM model, and then we use the sigmoid function because we're expecting two outputs. It's either positive sentiment or negative sentiment. Now, dataset pre-processing. Now, in this step, we basically had to clean up the tweets. A tweet contains a lot of information. It contains features like a hashtag, emojis, URLs, those kind of things. So what we do in this step of text normalization is that we perform lowercasing. Every letter that is in the tweet is lowercased. We remove URLs, we remove usernames with the @ symbol. We replace letters that are consecutive. We replace emojis and replace contractions. Contractions are words like cannot, shall not. We replace them with the actual word. Like the word is can't and can't or shan't. Then we replace it with the actual word, which is cannot, shall not. And then we also remove non-alphabets. This can include $signs and that kind of information. So just to give a little bit more information on text normalization, is that the steps that are taken as we're removing this information from the dataset, as we're replacing the URLs, it's really important to ensure the efficiency in the dataset. That means, like, if we remove punctuations before we remove URLs, the regression expressions won't perform as highly as they perform. So we have to remove them in a particular order. Next is what we did was just a simple analyzation of the tweets. So as we can see, when we use the word cloud here, we can see that the most common positive tweet is good, thank, love. And for negative tweets, we had user coming up, and you can also see that we have words like missed, phone, nice, racist, little, suck included in the word cloud. So let's talk a little bit more about word embeddings. So now word embeddings are a statistical modeling technique in NLP. They have two methods, that is the continuous skipgram and the continuous bag of words. The continuous skipgram orders words in the history. In history, that means that the history does not influence the output. It predicts the current word based on the context words or surrounding words, whereas a skipgram predicts surrounding words based on the given word. Sorry. Next, we're going to talk about tokenization and padding. Tokenization is a way of separating a piece of text into smaller tokens. And padding is a process by which you can add padding tokens at the start of a sentence to increase its length. So in this model, what we did first is that we first performed text normalization. We performed word embeddings. This is all before we pass it on to the embedding layer, and then finally to the BioSTM model. So this is the model architecture, the flow chart. So here at the top, you can see text in embedding input. At that layer, that's the layer after we have matched the tokens and their paddings, we've matched them with their corresponding vector representations, we've matched them together, then we pass them onto the embedding layer. Then that's the embedding layer that we pass into the BioSTM. And then from the BioSTM, we pass it on to the LSTM, which is now BioSTM is bidirectional, which it means it goes both left, right. But just LSTM is just one directional, so that it's only stores in one directional neural network of one dimension. So on training, we got a total of 6.5 million parameters, with about 500,000 being trainable and 6 million being non-trainable. We trained the dataset for about 14 epochs, and we got an accuracy of about nearly 84.23. And this just goes to say that if we trained a bit more, we could achieve higher accuracy. So this is a confusion matrix. You can see we had true negatives of 42.75. We had true positives of 41.65 and false positives of 7.23 and false negatives of 83.6%. This shows that our model is actually really accurate when it comes to predicting a negative and a positive sentiment. So this is our ROC curve. You can see that the model, that the data set is actually not skewed, and we have relatively low variance, like sorry, I'm getting my words a bit mixed up, but let me just, so based on this training curve, we can conclude that our model is neither biased or overfitting, because the accuracy flattened, but it continues to rise, implying that what I just told you earlier, that if we actually trained for more epochs, we would get a higher accuracy, because when we were training, the dropouts in the LSTM model, they were not active while evaluating. So meaning the validation loss is actually lower than the training loss. So this is a classification report. We can see that for our model scored an 84% for precision, 86 for this. 0 means that it is it is negative, and then 1 that's a positive sentiment. So for accurately classifying the negative sentiments, for precision it was 84%, recall 0.86, F1 score 0.85, and for the positive we have 0.85, 0.83, and 0.84 for the precision, recall, and F1 scores respectively. So on average, the model accurately classifies tweets as either negative or positive at 84%. So concluding the presentation, an enhanced version of our recurrent neural network model for capturing the contextual meaning of tweets by use of word embedding, specifically word to vec. And we used an enhanced version of the recurrent neural network, the BI-LSTM model. Now, for future work, we thought of using the BAT model because the BI-LSTM model is relatively slow and expensive. When about training and running the model took about 6 to 8 hours. So it's a bit slow, but it's also highly accurate. Yes, that's the end of my presentation. If anyone has any questions, please let me know.
Okay, so we have now 5 minutes for questions. If anyone would like to ask the questions, then please ask your questions. We have time for questions, so any one of you. Okay, so since there are no questions, then let's move on. Thank you, Matthew, for this enlightening presentation. It was nice. So again, I have one similar question. How can you ensure that your model is better as compared to other similar models?
Actually, when we performed a comparison with the Me2 dataset, we saw that because we used word vectors, what to work for word embeddings, they used compared to them, they used term frequency inverse, document frequency for performing word vectorization. We found that using word to vec to perform the vectorization of words, that's why we were able to score a much higher accuracy than the other models, because we used a different algorithm for performing word vectorization.
Okay, so is there any question? Does anyone have question? Okay, so let's move on. Thank you, Matthew, for your presentation. Now, it's how the presenter 10 is there, right? I will remove co-host from presenter 9 and presenter 10. Are you ready to present?
Yes, I'm ready.
So you're okay. Predicting diabetes onset through symptom analysis of machine learning approach. So I will make you as a co-host and then you can proceed.
Okay.
Okay. Yeah, you can proceed.
I'm trying to share the screen, but it's disabled. Screen sharing is disabled.
Ah, sorry, wait. Remove co-host presenters. Okay, presenter 10. Make co-host. Okay, you can try.
Okay.
Yeah.
Good afternoon, everyone. My name is Christina John from Kingdom University, and I'm going to be presenting on predicting the onset of diabetes using machine learning. So we're going to go through the introduction, methodology, the results, application of the model, and the conclusion. So diabetes is a chronic disease that is associated with the inability of the body to produce insulin to consume sugar properly. And this can cause the body to have several side effects like blurry vision and frequent urination and extreme thirst. There are three basic types of diabetes: type 1 diabetes, type 2, and gestational diabetes. Type 2 diabetes is the chronic form of diabetes, which develops after type 1 diabetes. So all types of diabetes are incurable, but type 2 diabetes is more severe compared to type 1. So it's very necessary to try to prevent type 1 diabetes to develop into type 2, because it's impossible to cure it, and the consequences become worse when it develops further. So the World International Diabetes Federation in 2021 reported that every 5 seconds, there's at least one death caused by diabetes in the world. So this is a considerable number. And currently there are 28.7 million diagnosed cases and 8.5 undiagnosed cases, which means a large percent of the world population is living with diabetes. So it's necessary to take measures to prevent it, as well as to try and control the disease. So the problem here that gives us the necessity to involve machine learning in predicting diabetes is the fact that anyone and at any age can be at risk of obtaining diabetes, because other than hereditary reasons, it can be caused by our lifestyle choices. And also there is currently no cure of diabetes, which means once you get it, there is no way out of it. So it's necessary to prevent it. And the way to prevent diabetes or prevent its development is by changing our lifestyle, by living a healthy lifestyle. And we can only do that if first we test and we know either we have diabetes or not. So testing early and knowing early if we have diabetes is necessary. So the solution is early diagnosis and regular checkups to see how our blood sugar levels are. So with machine learning, we can be able to create quick testing tools and obtain results quickly. We don't need to necessarily have an appointment with the doctors. We can test ourselves if the model is implemented on mobile or web platforms. And also machine learning provides accurate diagnosis compared to when humans conduct the diagnosis. And the contribution of this study is that it achieves better accuracy compared to other models that have used the same data set applied in this study. And also it opens up windows to self-testing deployment. When the model is deployed in mobile or web applications, then people can test themselves without needing a physician or any technical help. So the data set is of 520 individuals, and it consists of 16 attributes, 16 categorical attributes. These are just text, the different symptoms, because this data set is only consists of symptoms of diabetes. So the data can be just yes or no. If the person has symptoms, it's yes. If it doesn't have that particular symptom, then it's no. So it's categorical, and one numerical attribute, which is the age. So the proposed machine learning model uses a random forest classifier with cross-validation for improvement of the accuracy and performance. Okay, this is a flow chart of how the model will be performing or how this research was conducted. So the first thing we have is the data set, but the data set it has text data and only one numerical attribute, which means we need to handle that text data and convert it into numerical data so that we can be able to use it in the random forest classifier. Afterwards, we'll be able to train the model and test using cross-validation and then hyperparameter tuning to improve the model's performance. And then once that is done, we can deploy the model and evaluate its performance and comparing it to other related studies in this field. So below, in the next slide, I'm going to show a comparison of previous studies that used this similar data set to predict diabetes using machine learning, how they performed and how the model proposed in this study performed as well. So here we have about 6 studies that were previously conducted. The data set is the same data sets called the early stage diabetes risk prediction data set. And we have different authors and different research works that try to use the same data set and classify it using different machine learning models. So here we have the first study, classification of diabetes disease using decision tree algorithm. They used a C4.5 model and achieved an accuracy of 90.38. And we have these other ones, and also try to include most studies that use random forest classifying. We can see here that most of them achieved an accuracy of higher than 97. And below at the bottom is the proposed model, random forest classifier with 5-fold cross-validation, which achieved the accuracy of 98.71. So this model can be applied in mobile and web applications, and it will be useful in self-testing, which means the person can simply record their symptoms in the application. There is no biological test required because all the data used to train this model is text, and only one attribute is number, which is age. So a person can just observe themselves if they're having any symptoms and be able to record the data and check whether they're at risk or they already have diabetes. And also the model can be used in healthcare centers to assist the diagnosis by improving the accuracy of the diagnosis. So in conclusion, we need to know that diabetes is very deadly and there are no cure. And there's so many people that are currently suffering from diabetes, and we are all at risk of getting diabetes if we do not live a proper lifestyle. So it's necessary to take constant checkups and be sure that we don't have diabetes. And if we do, then we can be able to control the disease. And also machine learning solutions provide us with proper mechanisms to quickly detect, to predict faster, and also with great accuracy, as well as the ability to test ourselves without needing to visit the hospital or any physical physician assistance. So that is all, and I would welcome any questions if anyone has.
Okay, so thank you, Christina. We have now got 5 minutes for questions. If anyone of you have any questions, please, you can ask questions.
Hello?
Yes.
Yes, does anyone have questions?
Yes. Christina, thanks for your presentation, but I would like to know how does it, like, what does your model do that, let me say, the hospitals have not been doing? Or how easily can a person test themselves diabetes at home?
You can, let me address the second part of the question where you asked, how can a person access the model and be able to test themselves at home? If the model is deployed on a web platform, then a person can just visit the website and record their symptoms there, and the symptoms they recorded will be used to test, to check whether they're at risk of diabetes or they already have diabetes. And hospitals can be able to use this to initially diagnose the patient before taking a physical test or biological test. Because when you just visit the hospital, the first thing you do when you visit the doctor is that they ask you what symptoms you're experiencing to be able to know what kind of disease you have. So it can be able to assist the hospitals in prior tests or diagnosis before doing the biological tests. Hope that answered your question.
Okay, we have time for more questions. If you have any questions, then you can ask. Still, we have time for more questions. Anyone would like to ask the question? Then please ask your question. So Christina, so
Yes.
during your validation, what about the performance matrix? What performance matrices you have considered in the validation process?
Oh, in the validation process, I checked the accuracy, specificity, recall, and the ROC, area under the curve in the, and there's one score as well.
And then you compare with how many other models, similar models?
I compared with 3 models that used random forest classifier, but also other models that use different classifiers.
So which model is the best?
The best
Among
is
3.
random forest. The best is random forest classifier.
Mhm. What do you think? Why random forest is the best as compared to other?
Random forest is usually advisable when you have categorical data, and since this data set it comprises mostly of categorical data, then it presents a higher chance of performing better compared to other models.
Mhm. Okay. Anyone of you have any question?
Yes, I still have one more question. Sorry, Christina.
Okay.
This
Yes,
is, you have talked about categorical data. Is all the data
Yes.
you're having categorical, or you have some numerical data?
There is only one attribute that is categorical, and that is age, but the rest is categorical data.
And again, you said random forest works best when you are dealing with categorical data,
Yes.
but still it works better when you are using numerical data. How do you explain that?
Oh, I mean, let me try to answer the way I understood your question. And if it's not satisfactory, you can ask back. What I think maybe is like, when I say categorical data, I don't mean that it's text. I just mean they are like classes, maybe 2 or 3 classes of the same data. That is, for instance, in this case, we have symptoms, and the 2 classes of each attribute is that the person has the symptom, which in the model is converted to B1, because as I said, in the process, we have to convert the text data into numbers. So yes would be 1 and no will be 0.
No,
So the category will be 1 and 0. Did that answer your question?
Yes, but there you have what I'm trying to say is,
Yes.
after converting it from numerical by putting them in classes into 0 and 1, it means it's no longer categorical data. You have converted it into numerical data. Is that right?
No, no, that's not the case. Numerical data is like, for instance, age. It can be anything. It can be any number, right? Starting from 0 onwards. It can be 0, 4, 19, like there's a wide range. But categorical data means you have just a certain specified number of classes. For instance, let me give an example. You have colors, right? For instance, you have only 3 colors: red, blue, and yellow. Red, blue, and yellow are 3 classes. So it means if I have multiple instances, it means they can be either red, blue, or yellow. They cannot be both, and they cannot be other colors than these 3, which makes this data categorical. It's not a wide range, like it's not continuous. You see numbers, for instance, the age attribute in this data set, it can go on up to millions if people can be that old, but the categories in the other attributes are only 2, so it can only be yes or no. So it is categorical data. I just changed it to numbers because the models cannot process texts.
Okay, thank you then.
Yes.
Did you find like let me say the difference in age with
Yes.
diabetes detection? Is there like maybe a certain age where you find like diabetes is more of a problem too, or it's same? It doesn't differ with age. You can get it as long as you have not followed some procedures.
In my study, according to the data set, I haven't really checked which age group is highly likely to get or to have diabetes. But according to the research that I've done in diabetes, different reports, diabetes there is no age limit because children can get diabetes from their parents. Grown-ups can get diabetes from poor health or poor diet. And also people can there is another cause for diabetes, which is an automatic response of the system. And it's like the system attacks itself and your kidney, or I'm not sure, your liver cannot produce enough insulin to consume sugar well, and then you can get diabetes. So there is really no particular age group that is at risk of getting diabetes. Anyone at any age can get diabetes. There is also a certain type of diabetes called gestational diabetes, which occurs in women after they get pregnant. Like, I don't know how it works, but they can get diabetes after getting pregnant, and it's not caused by lifestyle. So anyone, even if they're living a healthy lifestyle, can be at risk to get diabetes.
Okay, thank you, Tina.
So
Yes.
I hope now presenter 8 got his answer. So thank you, Christina, for your enlightening presentation. Thank you so much.
Thank you, everyone, for your time.
So we have the last presenter, which is presenter 11. I see, I can see presenter 11 is there. So I will make presenter 11 co-host. And presenter 11 is going to present on video game special effects simulation based on particle system of Unity. Okay, let me make co-host. Okay, so you can proceed.
Good afternoon, everyone. I'll share my slide. Oh, are you able to hear me?
A bit. Your audio is not that clear.
Oh, okay. Okay. How about now?
It's okay. It's okay. I think it's okay.
Oh, okay.
You can share your screen.
Yes. Is everyone able to see this?
Yeah. Still, if you can manage your audio, it would be good.
Okay.
Yeah, that's fine. That's fine.
All right. All right. Good afternoon, everyone. My name is Wafula Celine Nerima, and I'll be presenting about my paper. It's about video game special effects based on the particle system of Unity. Okay. Are you able to view the screen?
Yeah, it's okay.
Okay.
Perfect.
All right. So my presentation will be divided into 3 parts. I'll start by introducing and giving a basic background on the particle system, Unity, and then all right. Sorry, I think I'll remove my headphones in order to be clear without.
That's okay.
Okay. Is everyone able to hear me now?
Yeah, that's fine. Perfect. Carry on.
And then I will share my applications and findings, and then my final thoughts at the end of the presentation. Okay, so first of all, I'd like to tell you why. I'm sorry about this. Okay, I'd like to tell you a brief background and what motivated me to take on this research is because video games are right now they're increasing, they're becoming more popular, and as they become popular, people want to have video games that feel very realistic, especially in the animation. So what this project is going to aim at is to build a user-friendly, to create user-friendly implementation of developing special effects. And so first of all, special effects are things that aid like gamers in video games to see what's happening on the screen. For example, when you're moving around the game, and also to simulate, for example, in the game when the player is running, you see the trails of what they leave around, maybe when they splashes of water when they walk on the ground. And so it's basically about the visual effects. And the Unity particle system is excuse me, I was receiving a message saying viewers can now see my screen. What does that mean?
Oh, really? Who is that?
Pardon?
Who said that? Who
I'd
cannot?
gotten a message, a pop-up message.
Really? But I didn't get it.
Oh, okay. I'll continue. All right. So the main problem is that up until now, video game objects are usually very static. So what we aim at is to create more dynamic, to make you feel like you're in the game, like to make it feel more realistic. So in this project, I implemented two projects. One which is a scene effect, that is rainfall, like you see the rainfall scene, and then the other one is a character skill effect, which is special lighting, a lightning effect. And we had to make it. The issue with this was it was very hard for someone who doesn't know how to code to create to create an effect. So what we did is to make it more user-friendly. And this is what so this paper is just going to show you the steps that were taken. And my main contribution to this, because in comparison with the previous studies, what they did, they used animation scripts, which not everyone has experience with the code, like for example, C#. So what I did is I eliminated the need to script animation for repos, and then I added spark effects. For example, when the lightning touches the ground, like when you're in the game, to view the sparks. And it can also be done when someone is running in the game, and then they touch the ground, or for example, they come in contact with something. The light you see, that's the special lighting effect that can also be implemented with what I did in this project. And I also used modules that are provided by the Unity game engine. I used noise and trails, which weren't used in the previous research. So those are my contributions. And as you can see in this table, the significant properties that are different from the old research is I used two particle systems, which can be easily understood by anyone who doesn't have background knowledge in for example, like what C# programming language is. So, and then, as you can see in this image, this is the previous research, and this is the findings. So when we will see that we needed planes, which are the grounds for the two particle systems to interact with each other. So these are my findings, but in order to understand what was going on, you have to know the basic principles of the particle system. And in a particle system, particles are usually, they aren't static. So in order to create that lifelike simulation, you need to have elements and molecules connecting with each other and bouncing around on each other, and each particle should have a life cycle, so that once one ages and another one has to continue, so that when they're rendered, it creates the illusion of a flow of non-ending elements in the system. So this is the structure, the process flow of particles in a system. Once they are created, they'll go through this cycle, because once when they're in the cycle of performance, when they age, you generate a new particle, and then you adjust the state depending on what the modules and the parameters you decide. And then that's how they'll continue being rendered here in the particle system emitter. So you need to provide these basic parameters for once you create a new particle system, but in order to make it, and this makes it the more user-friendly, and also it makes it easier on game developers. And here we can see that by default, there is emission, and then the shape of particles, and then the renderer. So while we're developing my scene effect, which is the rainfall, we needed there were two parts. First, we simulate the process of rainfall and how it will react when it touches the ground. That is to say, the ripples. These are the parameters that I adjusted in order to get my final, the final look. As you can see here, we use the default particle system, but we need a sub-emitter to create the ripples. But in the previous research, what you had to do, you had to animate you had to import materials to make for each particle, and then for those particles, you make an animation script, and then you had to connect them, which may be difficult for people who don't have the background knowledge, as I had mentioned earlier. So this is how it looked in the scene view, like when you've created, and then this is the final outlook once you've added the skybox and everything is interacting with each other. And then for the second effect development, which is a special lighting effect, I needed a parent particle system and a child particle system in order to create the lightning effect. So the noise is the one responsible for making the particles look like a strike, and then the trails are the ones responsible to show the shape of the lightning. As you can see here, in the rate over time, we'll see that once the particle reaches the ground, it will show the lightning strike, the spark, and then the lightning strike. And here I decided to show once I've adjusted, which can be done by any user and game developer. You adjust into any number of rate over time of particles, in each life cycle. So here, this is how the lightning strikes will look like. So for my final thoughts, I would like to note that this is in order to improve the way particle systems are the visual experience of gaming, and also it can also enable better marketing of video games, and just to improve overall user experience of video games. And for further study, I would like to recommend the virtual reality experience of these special effects, which can also be done by the Unity game engine because it's very interactive, user-friendly, and makes it easier on game development. And I'd like to thank Yangon University for funding this research. And thank you. I'll welcome questions.
Okay, thank you. Now we have time 5 minutes for questions. If any one of you have question, please ask your question.
Can I ask?
Yeah, sure.
Thank you, sir. So this is Kaushik Career from India, and it was a wonderful presentation, and it is one of my favorite topics, games, and I'm myself a very big fan of games. So I just want to know that like two-particle system. So what is the unique thing in the two-particle system? Because I've seen a lot of particle systems in other games and all that is being done. So what is the speciality of the two-particle system which you have introduced here?
In this one, I'd like to, because once someone is creating a particle system, usually since these are two different effects, because the rain particles are their own particles, that's its own system, and then the ripples, to create the ripples, that's its own particle system. But usually in the olden times, you'd have to make a script that joins them. But in the newer approach, this one just makes it so that there's an option, like in the module, if I could show it here. In the module, you can see here, there's a sub emitter. So it just enables you to trigger another particle system in that same script instead of creating a whole other project. So that becomes easier. And then, so that once the parent particle system is triggered, it's played, this sub particle system, which is called the sub emitter, starts playing based on I'd like to say the reaction of the parent particle system. Does that answer your question, or I understood it wrongly?
Yeah, it was excellent. The answer was really excellent. And I just wanted some suggestions from you that how much physics is needed to learn Unity and game development. Like not related to this paper, but I just wanted some suggestions because I really liked your project and your conference paper. Okay. The presentation which you have shown. So I wanted to ask that how much physics is needed in Unity.
For Unity itself, there is not much physics because you can just create it's a better experience of object-oriented programming. But in order to create I'll say very realistic things which look more dynamic, you have to know a bit of these terms, like to know what the noise does, to know what the trails do, to know what external forces do. But like the physics itself, you do not have to learn all the background knowledge. You just have to know what each parameter does. But if you would like to learn the physics itself to make the experience more enjoyable, it would be recommended. But in Unity itself, you just have to know what each module does in order to create a particular system. Does that answer your question?
Yeah. Thank you, ma'am. All the best for your future endeavors.
Okay. Thank you.
Okay. Thank you for your nice presentation. Now we move forward. So basically, it's the end of all the presentation. I can see here presenter 3. So presenter 3, do you want to present? However, your allocated time has been fast. Still, I can manage 15 minutes before we wrap up this session. So I can manage 15 minutes, including presentation and question and answer. If you wish to present, then I can manage time for you. Is there presenter 3? Can you?
Yes, I'm there.
So you want to present?
Yeah, if you allow, then I can present.
Okay, so I can give you 15 minutes, including question and answer.
Sure, sir.
Then
Can you please enable the screen
okay.
sharing?
Okay, I will make you co-host. Presenter 3. Co-host. Okay, now you can proceed.
Yeah. So wait a second.
Yeah, you
So
can
am
share
I
your
visible?
screen.
Am I
Yes,
visible?
you can share your screen.
Wait for a second. Let me just pull
Yeah,
up the
sure.
Okay. Because some of the light is coming. Hello, sir.
Yes,
I'm back.
yes, please.
I-
Okay, you can share your screen.
Yeah. Okay, I can share the screen. Hope it is visible, sir.
Yeah, perfect.
Thank you, sir. So begin with it. So hello everyone. This is Kaushik here, and me with the team of with a team, we have worked upon the dynamic ticket pricing price prediction. How can I collapse this? Okay, anyways. Yeah, so we worked upon the dynamic ticket price prediction for Spanish Renfe Railways, which is a comparative analysis of machine learning algorithms. So basically, dynamic ticket price prediction model. So it is like, ticket prices, we all know how it fluctuates, how it changes according to the location, according to the time, according to the season. So it is a model through which we can make a way through which the customers or the travelers can understand that what will be the ticket price for a particular condition. Okay, so let me move ahead. So these are the plan of talks we have, abstract and introduction, literature review, problem gap, and all these things are there. So we will be talking about these. Okay, so what is this? Actually, we have the huge demand for energy efficient transport globally. And we all know that airplanes, they do cause some amount of pollution. So that's why people are relying on trains. Also, they are very much cheap. So people do rely on train. However, the problem with the train prices is that unlike the airline prices are a little bit more static or less dynamic than the train prices are. But the train prices, they change a lot. It is just like similar to stock market only, similar, not exactly like stock market, but according to the time and according to the demand and according to many factors, it changes. So that what happens. Okay, so it creates a lot of variation. So that's why we decided to make a model through which we can predict that what will be the best price and best time and best conditions for which through which a customer can get the best price he can get under his budget. So basically, the data set we used was based on Renfe AV, which is the Spanish high-speed train service ticket monitoring system. This was the data set we used. Okay. And these are the algorithms. The algorithms which we used are multilinear regression, polynomial regression, k-nearest neighbors, decision trees, random forests. Apologies for this. It's not ramp, it's random forests. Anyways, AdaBoost and XGBoost. And what the goal is to understand which model performs the best in terms of predicting the price of these. Okay. So let us proceed. I hope everyone is understanding this. Okay. So as I've already talked about it, it has been a favored mode of transportation, and that is the one more problem is that it is a complicated process. It is a complicated process because it is influenced by a number of internal and external factors. Also, there are many cases where people have to immediately book train tickets, but they don't get the what do you say, the optimum price. It might be because they are booking at a wrong time. So this is where dynamic price prediction comes. So it can happen that after a few hours, the train ticket price might fall down, or it might go up. So accordingly, we can tell the customer or the traveler that what will be the suitable time to book the train tickets. So with the help of these, the forecasting, which we got from the Spanish high-speed railway data, by training all the models, we can understand that which time will be suitable to book train tickets. And with that, people can manage their revenue, and also people can be more aware of when to book train ticket prices. Okay. So these are the literature review. Okay. So it is like the ticket sales, the prediction and dynamic pricing strategies in public transport are using big data and cognitive computing. Even similar work, these are the similar work. So even by using big data and cognitive computing, we can do all these things. Even air prediction has been done by that. But what is unique in our work is that it is based on the train ticket prices, and airfare are like they are not much fluctuating as train tickets are, especially in countries like India, where we see that people travel mostly by train. Train is like the lifeline of the country. So what we see here is that people travel by train, and since a lot of travelers are there, so the price may vary a lot, even within a few period of time. So we will move ahead. So what is the problem gap? So increasing demand in the train sector, as I've discussed earlier, more energy efficient transport is needed, and people are looking for more economical transport services. So train comes here. So since there is a rise in demand, so we should also address to the pricing problems and the budget problems which people have. So that's where the dynamic pricing strategy comes here to meet the demand. And then unpredictable prices means the price which cannot be predicted normally by people can be predicted by this model for the consumers who are looking for affordable tickets, so that so that they can save the money, and they do not spend much time on doing other sorts of research. With the help of this model, they can put the input data and understand when the ticket price will be affordable for them, or the best ticket price, the optimum ticket price they will get. So what is the solution to the gap? So we have to develop a model which forecasts the cost of train tickets by using machine learning techniques, and using these forecasted ticket costs, we can travel. They can travel their travel budget and make informed decisions about purchasing tickets at the best prices. Okay. So as I said, the data set used is AVE, which is Alta Velocidad Española, Spanish high-speed train provided by the state-owned business Rente. With the help of the dataset, we trained multiple models, and we tried to know that which model would work the best for, what do you say, the dynamic price prediction. So here in this case, the AVE, the Spanish high-speed train services actually has 5 different classes and tariff categories, and that vary along to the distance traveled. So there are many cases, like if you are taking a particular class and a particular distance at a particular period of time, and on what time you are booking, so it varies a lot. There can be cases where a lower class can have a much more price than a slightly bit higher class, because there are 5 different classes. That can happen based on the demand and the timing which you are taking. So accordingly, optimum decisions. We want a better class, better train ticket price, and according to our location and where we are going, we want to know the prices. So these are taken into account, like the train classes, rates, and many factors are there which we have considered, and using that we have built the prediction model. Okay. So what is the methodology? So these are the dependent data. Okay, we have the price, of course, then we have the train class, we have the fare type, and then we also have the train type. So train type means these are the locations, like regional or express, and from where to where you are going. There are fare types like flexible, promo plus, adult to AIDA, and MISA. We also have the train class like Turista, Preferente, Turista Plus, and Kama Turista. These are the train classes. Like we have first class, second class, third class. In Spain, we have Turista, and all these classes are there. So based on various factors and various things, we come to know that how we can predict the price. Just like you can consider it to be synonymous or analogous to stock market prices. Although it is more dynamic, but you can consider analogous to it. And this is what we are trying to do. Okay, so first we begin with data pre-processing. Okay, so data pre-processing, what we did, first we described the data. We understood how what the data set was, what was the nature of the data. And then we dropped the NA or null columns. And we directly dropped it because the data set was really huge. It is really huge. So we had to drop a lot of irrelevant and unnecessary data points, so that there is no overfitting of the model. We understood the shape of the data set. Then what are the types, because it is important to understand. And then we checked whether we still have null values or not, because null values can create issues in our model. So some of the independent data which we have seen are start date, end date, origin, and destination. So as I said, according to the timing, the prices can change, and it can fluctuate. So first we did the exploratory data analysis. Okay. So historical price means the before the old prices were taken, and it was this. We made a plot, this plot, to find that Kama Turista had the highest price with the least number of consumers buying. Through the disk plot, we came to know that this particular class in the Spanish railway, high-speed rails, it had the highest price, but it had the least numbers of consumers buying. Okay. So now we will move ahead. So now implementation comes. So as I've stated earlier, we have to train on multiple models, and we have to look that which one will be good for the particular problem. So multiple linear regression is a statistical method that shows the relationship between a dependent variable and multiple independent variable, which are not highly correlated to each other. Then we use the polynomial regression. Then we use the KNN. Then we use the decision trees. All the definitions are written here. I hope you all know about these models. So anyways, we all know about the models, but the main thing is about the solving the problem. So we also use random forests and XGBoost. You can see the pictures of stump and ensemble methods. Even we use the ADA boost. So as you can see, we use the almost many of the models, the supervised learning models, to understand that which model works the best for the given data set after doing the data pre-processing and exploratory data analysis. So these are the table of result, and we can easily find out from the R2 score that KNN, which is the K nearest neighbor, is performing the best. Even if you look at the other parameters like MAE, MSC, RMSC, and R2 score, K nearest neighbors work the best in this case. Others are not working that good. And here in this case, the worst performing model, I can say from the R2 score itself. From R2 score perspective, we can say that AdaBoost did not perform that well. It heavily relied on KNN. So why it heavily relied on KNN? It's because of the data points. As you can see, that if there is a data point which has some particular class.
Sorry to interrupt you. Can you please come to your conclusion?
Yeah, sure. Conclusion. So this study is focused on dynamic ticket price prediction in the Spanish Railways data set. And the findings of this study highlighted the potential of machine learning algorithms in predicting train ticket prices in the transportation sector. We used the historical data and considered various input features, and these models can provide valuable insights for pricing strategies. And as I said, the KNN model works the best, and it enables both the passengers and transportation businesses to make informed decisions. Future scope, in terms of future scope, it opens up avenues for further exploration in the field of dynamic train price prediction, and it can help a lot in the transportation sector, and it can help people save their expenses. Additionally, we can incorporate real-time data and external factors such as economic indicators, events, weather conditions, and with the real-time data integration, it can work better. And if we make a good app from it, then it will be one of the most used apps by the people who travel by the railway the most. So these are the references. So I hope.
So thank you. Thank you for nice presentation. If we are running out of time, so I will give chance for only one question. If any one of you have question, then please you can ask your question. Any one of you have question, I will give chance only one question. I think there are no questions, so let's move on. Thank you so much. Thank you for your presentation. So we are almost end of the presentation today's session. So I would like to wrap up. It was a nice experience for me, and I believe it's same for all the participants. And I would like to thank all our speakers for their nice presentation and discussion. Thank you very much for providing me this opportunity to chair the session, and see you all the participants in the closing ceremony. So our closing ceremony will start at 3:30. So I request you all, please join the closing ceremony. We have one more guest speaker there, and then we will discuss and we'll talk more things in closing ceremony. Once again, thank you all for your nice presentation and discussion. So now I will going to close this live session and see you in closing ceremony. Thank you all.